Okay, hello class. So this week's concept is based on Earth-Sun relationships. So to provide basic definitions, weather, the state of the atmosphere at a given place and time with regard to certain variables. Climate, it's the synthesis of weather conditions at a given locality over a specified time frame. So temperature is critical. A primary factor influencing temperatures is the amount of solar energy a place receives. So there is an unequal distribution of solar radiation on Earth, and it varies from place to place. So the amount of solar energy is determined by intensity and duration. These are the two most important factors to consider when understanding solar radiation. So duration, it refers to the length of daylight, and intensity, strength of solar radiation depends on the angle at which the sun's rays strike a surface. So for this example, we have the high sun, and this is directly overhead on the Earth's surface. So this produces a higher intensity compared to if it was at a lower angle, such as this low sun, and it has a low intensity. So in this example, we have the vertical rays hitting the Tropic of Capricorn. So again, think of the vertical rays as the sun being directly overhead the Tropic of Capricorn. And in this example, the sun is directly overhead at the Tropic of Cancer. So this is an expanded diagram, but basically in this part of the diagram, the sun is directly overhead at the equator, and this is known as the spring equinox. On March 21st, 22nd, the sun is directly overhead at the equator, and as the months pass by, the sun is directly overhead at the Tropic of Cancer, which is known as the summer solstice on June 21st or 22nd. And the months pass by and the sun is directly overhead at the equator again, and this is known as the fall equinox on September 21st, 22nd. And again, the months pass by and the sun is directly overhead at the Tropic of Capricorn on the winter solstice, and the dates for the winter solstice are December 21st, 22nd. So the reason we have seasons is because of Earth's tilt. So as you can see, the tilt is facing away from the sun, so it's hitting the southern hemisphere. So that's why for us, it's known as the winter solstice, because we are not getting as much sunlight as the southern hemisphere. And again, for the summer solstice, the tilt is facing the sun, so that's why we're experiencing summer, because we're getting the vast amount of sunlight. So again, the sun is directly overhead only between the Tropic of Cancer to the Tropic of Capricorn. So it's just traveling up and down as the months pass by. And a way to see this is based on the analemma. So this can be used to determine the latitude where the overhead noon sun is located for any date. So again, this small Earth right here, as you can see, it's between the Tropic of Cancer and the Tropic of Capricorn, and this is the formation that is observed where the overhead noon sun is observed at the sky. So a way to look at this chart is that at this axis we have 24 degrees north, 22 degrees north, all the way to the equator at 0 degrees. So this is representing the northern hemisphere, and then going down the southern hemisphere, so 24 degrees south, 22 degrees south. So the main important lines that we know is that the Tropic of Cancer is located here between 22 and 24 degrees north. So at 23.5 degrees south, we have the Tropic of Cancer. And then the Tropic of Capricorn at 23.5 degrees north, that's the Tropic of Cancer. And then 23.5 degrees south, right here, that's the Tropic of Capricorn. So again, we know that the overhead noon sun is on December 21st, 22nd at 23.5 degrees north, at 23.5 degrees south, I mean. So to use this diagram, we're basically asking the question, where is the sun directly overhead on September 15th, for example? So all we do is go across, and we see that at 3 degrees north, the sun is directly overhead at this latitude. So you guys will be answering a couple of questions using this analemma. And another concept is the aphelion and perihelion. So we have, so the Earth's orbit around the sun, it is not symmetrical. And so on January, the Earth's closest to the sun at 147.1 million kilometers, and in July, the Earth is farthest away from the sun at 152.1 million kilometers. And another concept is the length of daylight. So again, this is telling you the latitudes. So the location where you are at on Earth, summer solstice, we know the dates, June 21st, 22nd, winter solstice, December 21st, 22nd, and the equinoxes, the spring and fall equinoxes. So for example, at 30 degrees north, on June 21st, 22nd, we are experiencing 13 hours of daylight, and on December 21st, 22nd, Los Angeles is experiencing 10 hours of daylight. So that's how you'll be answering a couple of questions on that one. So we have the solar energy budget. So in this diagram, it's showing that the Earth receives 100% incoming solar radiation, but this solar radiation is either absorbed or reflected by the Earth's atmosphere or the surface. So 51% is absorbed at the surface, and the total energy that is reflected is 30%, and 19% is absorbed by atmosphere and clouds. So this is what you guys will be focusing on for your lab up to energy budget. And yeah, so let me know if you have any questions, and I'll be happy to help you during office hours. So bye guys.